And here's something to be aware of. Correlation does not imply causation. For example, we find that the number of watermelons consumed is correlated with the number of drownings, and our R is statistically significant. So we did a study and we looked at the number of drownings and we looked at how much watermelons were being consumed. And so we're wondering, does eating watermelons cause drownings? I think we know that that's not the case, but why are we finding a significant correlation between watermelons and drownings? What else could be the cause? Well, we could be eating watermelon because it's summer, and we could be swimming because it's summer too. So watermelons are consumed most during the summer, a time when we also swim a lot. Both occur in the summer. One does not cause the other. That's sometimes the case. When we find two things that are correlated, they might be correlated, but it could be for a reason other than one causing the other. So be careful about saying that one is causing the other, and just say that the two are correlated, because for right now, that's all the statistical knowledge that you're going to have, is how to talk about correlations, not causation. So before, when I talked to you about lung cancer and the number of cigarettes you smoke in a day, those are, they are, causation has been shown, but it has to be done with a long clinical study where people are randomly selected and then followed for a long period of time. You can't just look at how many cigarettes a person smokes and if they have died from cancer. You have to go into more depth than that. And so statisticians and researchers did do that and looked and found ways to prove that smoking did cause lung cancer. So that one has been proven, but it started out with just being a correlation, and eventually they were able to show that there was causation also. But you will not be able to do that with what we're going to learn in statistics. You will just be able to say whether or not there's a correlation.